Welcome to our today's webinar. Thank you for joining, first of all. So today we have a very interesting topic, the virtualization showdown of oVirt versus VMware vSphere. And your hosts for today will be me, Orest, Solutions Engineer at StarWind, and my colleague.
Yeah, hi, my name is Yaro. I'm also Solutions Architect at StarWind. And yeah, it's a pleasure to meet everyone. Pleasure to meet you, Orest.
Yeah, same. Okay, so let's actually make a brief agenda overview before we move on to the presentation and to the topic itself. So we're going to make a short recap on what we had on the previous webinars, because we had a series where we also have taken a look at vSphere and Microsoft with Windows Server and Hyper-V. Now, since oVirt is quite an interesting topic and maybe not the most popular virtualization solution, we're going to also discuss what is oVirt, its main components, and then we will have actual, comparison for the features, management and monitoring, licensing, storage for vSphere and oVirt. And then we're going to have a short demo and traditionally at the end, a short Q&A session where you will be able to ask your questions and hopefully we can answer them. So let's start on the recap and intro. Yaro, you want to start?
Yeah, I would like to have a word because I was doing part of the series. So I previously in this webinar series, we've been discussing Windows Server and Hyper-V and VMware vSphere, and actually VMware vSphere is larger player on the market as compared to Hyper-V, because I think 70 to 80% has been held by VMware of the virtualization market. And well, there is still Hyper-V and other hypervisors like KVM, other varieties of KVM, like different flavors and so on and so forth, and some open source hypervisors. Well, spoilers ahead. And but this third place is, which is kind of like umbrella term for many hypervisors, is growing. Because things are changing. Windows Server 2022 and Hyper-V for Hyper-V as well, because Azure Stack is there, and Microsoft is pushing everyone to cloud. Like, don't get me wrong, cloud is great, but maybe not working for everyone. Who knows? And as for VMware vSphere, they about to change the licensing, I think, and they might be acquired by Broadcom, which might result into also some changes to corporate policies and other stuff, which is well, just some speculations, because, well, who knows, will this acquisition happen or not? But the world is changing, and some people don't like the change. So that's why this third place is like getting more and more light onto it. So Orest, apart from, I know, KVM, any specific titles coming to your head?
Yeah, well, actually, we're gonna talk about, well, basically about KVM today, which is the main, well, let's say the hypervisor core for the oVirt. So oVirt, that's actually what you probably said, right? Since things are changing, people always want to keep the finger on the pulse of the market of what there is besides the well-known virtualization solutions. So today, exactly, we're going to talk one of them, maybe not the most popular one. We're going to talk about the oVirt. Now, again, so maybe not the best known virtualization solution. Some people might be familiar with it, some might not. It is actually for a long time on the virtualization, well, sector, sphere, or market, to put it like that. It was founded back in 2011 by Canonical, Cisco, IBM, Red Hat, of course, the main, just to name a few actual participants. And it's basically to create the open source community for the development of open virtualization platform, right? You can tell it from the name of oVirt. Now, based on the KVM, so kernel-based virtual machine hypervisor. Now, apparently, oVirt is free and open source. Now, to put this properly, oVirt is the full-fledged virtualization management platform. So basically, centralized management for virtual machines, compute and storage resources, networking stack, and of course, all from the web-based front end. Now, again, it's not just the hypervisor. So oVirt is based on several, let's say, main projects. Now, we're not going to make a deep dive into each of them, but just to provide the understanding, the main one is KVM, which you already mentioned, and which is a virtualization technology for Linux on x86 hardware containing virtualization extensions like Intel VT or AMD V. And basically, KVM lets you turn Linux into a hypervisor that allows a host to run multiple VMs. Well, simple as that. Now, apart from KVM, there is also libvirt project, which is basically a collection of software that provides a common API for managing KVM, but of course, not limited to KVM only. Then we have, for the storage part, that's Gluster, which is the scalable and distributed network file system, basically allowing us to create large distributed storage solution on top of the off-the-shelf hardware, basically. So in other simple words, it aggregates storage components from several servers into one uniform file system. Of course, also free and open source. Now, and the nice thing that Gluster data can be accessed practically from anywhere. You can use traditional NFS or SMB/CIFS for Windows clients, for example, or its own native GlusterFS exports. Now, the other component is Patternfly, which is the open source interface design system by Red Hat, which allows us to provide visual components and tools for designing these components and code examples to make it possible for pretty much anyone to design and build accessible user experiences, to put it like that. And then we have Ansible, basically an automation system. It handles the configuration, management, application deployment, cloud provisioning, network automation, whatnot. So basically makes complex changes a bit more easier, more, of course, automated. Now that we know what oVirt is overall, now I'm going to take some time and actually talk about the main components to understand the architecture itself. And that's probably the most interesting part here. Now, first of all, we are talking here about the oVirt 4.5, the latest release. Now, oVirt has two main components: hosts and engine. Now, there are two types of hosts: oVirt Node, which is basically the minimal OS based on CentOS, which is basically the simple way to deploy physical machine to act as a hypervisor in your oVirt environment. And then you have another type of oVirt host, which is based on enterprise Linux. So as you probably understand, the standard basic installation of enterprise Linux OS on a server, then upon which we have the hypervisor packages. Now, you can mix oVirt nodes and enterprise Linux hosts in the oVirt environment. You might want to use only a single one, just either oVirt node or enterprise Linux. Depends on the requirements. Like enterprise Linux, it's more open to any changes or additional packages you might want to install, while oVirt node is more of the minimalistic system to turn your physical node into the hypervisor itself. Now, what I would say the main component actually when it comes to overall management of VMs, their creation, administration tasks, storage and compute resources management, that's the oVirt engine. So it acts as the, well, control center for oVirt environments. So it allows you to define hosts, networks, add storage, create VMs, manage user permissions.
It's, well, let's put it in simple words. It's some sort of vCenter in oVirt world.
Yeah, right. Yeah, exactly. So while you would access your vCenter with vSphere Web plugin, just to have the graphical interface and perform all the management and administration tasks, create clusters, add hosts, and so on, oVirt engine does the same job in the oVirt environment. Now, again, it can be deployed on the oVirt node or enterprise Linux. This can be a standalone machine, I mean, a separate machine with oVirt engine, or this can be same as the vCenter appliance, meaning the self-hosted oVirt engine, which will basically run as a VM on one of the oVirt hosts, and then you can also add more hosts for the self-hosted engine to also make it highly available. Now, if I'm not mistaken, the maximum here would be 7 hosts that can run, basically hold oVirt engine in case the failures. So then the oVirt engine will fail over to the other nodes. And yeah, so hopefully this is enough for the slight background about oVirt. Also, regarding the requirements, you can see them on the right of the table for oVirt node and for enterprise Linux and for oVirt engines. So basically, I'm not going to name all, CentOS Stream 8 or 9 in any case, and of course, Red Hat Enterprise Linux 8.7 or higher. And also as to the system requirements for engine, I think that's also the interesting part. Minimal, you would need a dual core CPU. The recommended is quad core, at least 4 GB of RAM and recommended 16, and at least of 25 GB of locally accessible disk space, and ideally 50 GB. So that's for the requirements.